The beginning of the jet engine began in Germany in early 1930s at Göttingen University by Hans von Ohain. Ohain developed multiple test engines in his conquest to build the fastest plane in the world. After a few years of developing test engines, Ohain in February 1937 successfully tested the S1 engine. He then switched his focus towards the S3 engine, which improved upon his original design, but faced the problem of developing a liquid fuel combustor. However, he overcame this obstacle. In 1938, after developing the S3 engine, Ohain started designing the HE-178, the aircraft that would use the S3 engine. The engine in the aircraft construction was finished in 1939. However, the engine did not provide enough thrust to get the aircraft off the ground. To fix this problem, Ohain had to make several internal adjustments. But on August 27, 1939, the HE-178 had its first successful flight. It also marked the first successful flight of an aircraft using a jet engine. In England at the same time, Frank Whittle had created a design of a jet engine that he filed for patent in 1930 and was granted in 1932. Frank then took 5 years to develop his first experimental engine. It included a central fused compressor and an axial flow turbine. Whittle then reconstructed his engine multiple times until yielding a finished product that had a total of 10 combustion chambers. In 1939, the Air Ministry gave support to Whittle, which led to the building of the W1 engine, which was completed in May 1941, and it led to the building of the E-28 by Gloster Aircraft, which was completed in March 1941 and used the W1. In America, the design and developing of jet engines is beginning at the same time of the completion of the W1. General Electric was picked by the U.S. Army Corps to build a jet engine utilizing Frank Whittle's design. In April of 1942, GE successfully tested the IA engine, which used a central fused compressor. Then in 1942, in California, the IA engine was used to power the Bell XP-59A, propelling the United States in the jet age. GE then created the J-33, which was the first occupational jet in the United States Army, the P-80 Shooting Star. In 1948, Pratt & Whitney developed a way to create a jet engine that could create more thrust and consume less fuel. This challenge had been posed since after World War II, and the engineers at Pratt & Whitney solved it by the dual spoon concept. The dual spoon concept combined two engines essentially together. The new engine would have two compressors that rotated independently, and the compressor would draw from separate turbines. This led to the creation of the J-57 engine. The J-57 engine was used in the Boeing B-52 and the U-2 spy plane. Next in the innovation of jet engines, Gerard Newman, a GE engineer, solved the problem of compressor stall, which is a local disruption of the airflow in a turbocharged compressor. To solve this problem, he introduced the variable stator. The variable stator had small vanes that protruded into the airflow within the compressor. Each vane could then turn. This allowed the vanes to control airflow. If they were facing forward, the air could pass through freely, but the vanes were turned to face their broadsides out. The airflow was partially blocked, ultimately not letting the compressor fill it with too much air. This led to the invention of the J-79, which was used on the Lockheed F-104, which flew twice the speed of sound. The next frontier of jet engines called for the large amounts of power to be able to be created so that the jet engine could be used on large aircraft. This led to the invention of the turbofan. The turbofan was a large turbine that used a large turbine that could create more power, and then the large turbine turned a giant fan. The turbofan helped with fuel economy and created double the thrust, and was also quieter. GE, Pratt & Whitney, and Rolls-Royce all built these in 1965. The first aircraft to use them was the Lockheed C-5, which finished being built in 1968. Newer innovations in jet engines include the world's first adaptive three-stream engine to the Adaptive Versatile Engine Technology (ADVENT) program with the United States Air Force research labs developed by GE. Also, the creation of new materials are being utilized by General Electric that are twice as strong as current pieces used in jet engines but provide the same heat capacities and strength. The future of jet engines looks very bright, with the future of many innovations to make jet travel more efficient and better.